ஏய் பழைய சாதமும் முதல்ல பழைய சாதத்தை எனக்கு போடு.
Okay. Sorry. Good evening, Ji. Oh yeah. So we were seeing Hive. We saw what is Hive and how Hive works, everything we saw. And there are few topics which we need to cover. And before that, I'm just muting everybody who's there in the class. Yeah. So there are a few things which is one is file format. We need to work in the file format. Like there are multiple file formats we will use in Hive. For example, there are text file formats, and then Avro, and then RC, and then ORC, and then Paraquet file format, and then we have sequence file. So there are multiple file formats which we can use. Some of them are compressed, some of them are not compressed. Those formats we'll be able to use in Hive. This one I'll separately take after this session. And today what we are going to see is we'll see how the UDF works, how to write a UDF function, and what is the use of UDF in Hive. After that we'll see yarn. So yarn is nothing but Hadoop 2.0. Hadoop 2.0, that we will see. Okay, so first regarding UDF, I'll just open the PPT from our SAR drive, session information, PPT. I'm just opening Hive introduction. So there are three types of UDFs are there. One is simple UDF function, one input and it will give us one output. And we can also write aggregated function and also transfer table function, like user defined table function, user defined aggregated function. Aggregate function is multiple input, one output. Table function is one input, it will give us multiple output. So now we will write one UDF program for first thing, like one input which will give us another input. So in order to write UDF program, or we need to write a Java code for that. Java or Python also we can write UDF program, but in our example we are going to write Java. Okay, and yeah, Ganeshi, good evening, Ganeshi. So in our program we will write a Java code for that. So how do we write a Java code? Same as how we created in the previous class. For MapReduce, how did we create it? Same way we are going to create. I'll be using the Eclipse IDE for that.
Sorry, so class started?
Yeah.
Oh, okay.
Yes, Ji. So just starting a UDF function. How to write UDF?
Oh, okay.
Okay. So I'm just creating on Java project. Stream. So here I'm just creating one class. Same thing. I'm just creating one classes. CRIB. And I have a class ready. So what this does is it just gets a value. It just gets a string, and then it will trim the character which is extra, like all the null characters or spaces. It will just trim, and then it will give us as a result. That's what this simple function does. And we have overloaded the same function. So overloading means, I believe everybody knows the concept of overloading in OOP. Overloading is nothing but the function name will be same, but the argument will be different. There can be more argument, there can be different kind of argument will be there. So if the argument differs, then the action will be performed in a different manner. So same goes here. Here also we wrote a overloading method. We wrote two functions. One is evaluate, which is taking only one input. Another one more function is also there, that is also evaluate, and that is taking two arguments. Okay, so this is called as function overloading in Java. So if we just give simple text, it will just look for spaces and it will strip that. It will just remove the data, remove the spaces and return it. And if we gave two arguments, then what it does is whatever the characters we have given in the second as a second argument, it will look for that, then it will remove that from the first text. This is just a function which we wrote. We will, while executing, we will get to know that. Okay, this is a simple Java program I am just creating. So I just copy paste it here, and as usual, I don't have the necessary library. So I am just going to add the jar file so that it can work. So till now everybody is clear what I'm doing. I just created one Java project in my Eclipse, and then I copied the Java code.
Yeah.
So as usual, I need to add the jar, external jar. So for that, I'm going to Java build path, going to external jar. So here previously I used to download, right? In 5.13 version and all, we have the jar in Hadoop itself. So we can just select the same jar. So I'm selecting this one. So here all we need is Hive jar and then Hadoop jar. Okay. So I just went to two locations and select. One is I went to like /user/lib/hadoop, and then I selected this jar like common.cdh 1.5.3 jar that I have selected. And other than that, I also need Hive jar for that. I will just go to user lib and then Hive, and then I will go to bin. Sorry, not bin. Lib. Here I'll just add all these jars, Hive jars. Okay. Now there are some.
So Hive jar, you have given link, right?
No, it's not linked.
To download it and add
Yeah,
it.
but here you don't have to. It is there in the 1.3 version. Everybody is using 1.3, right? So there
Yeah.
itself you have the jar in /user/lib. In that you have all the jars like Hadoop. All the jars are there. You don't have to download it also. You can use
Okay.
it here. Even for map reduce, you don't have to download the jar. You can use this same jar. This will work.
Hey, I'm just new to this. So how do we know that which jar is suitable for us? Which one we need to select?
Here that we need to know only based on the this implementation. We need to search it in like what we used to do is we'll search it in Google and find out what is the jar required. So here the jar, from there only we'll get to know what jar contains this method. Then only we will be able to know that. This method we need to Google and find out what is the required jar for that. Then only we'll be able to understand.
So when we are writing an some UDF, so that time is it okay whatever the jars you mentioned that, so that we will add in our Java program, so that is enough, right? It won't cause any issues, right?
Yeah, that should be enough.
Okay.
You can add that.
Oh, I think.
So,
I think Anbu. So in that scenario, we can note it down and we can use it.
Currently, you can note it down for this example. But what will happen in production like scenario? For that, we have something called Marvin dependency. Marvin and SBT. Sorry, not ABT. SBT and tool. So these things, what it does is Marvin is a dependency resolving tool. So what it does is it downloads all the required jar and it will keep us ready.
Okay.
If you just learn about Marvin in project and all, we'll use Marvin only. Marvin is a software management and comprehensive tool. So what it does is it will give us the dependency jars. It will download it from the open source itself. Then it will keep us in our library. For example, let's say I want a jar for Spark Marvin dependency. If I search like this, I will get the repository names. Okay, so this is Marvin repository, and here I'll get Spark core project, Spark project SQL, Spark project CDB, and I just select one, and here I have the lot of versions. Which version of the jar I want? So I can go into this, and then I will get for different tools like SPT, Gradle, IV. These are different build tools. I hear some noise.
Okay.
So got it, Ji and Buji. This is dependency resolving tool.
Arji, so after this, what do you do? Like, you said, like, you can go here. Okay. So, but do we copy this code and put it there, or what is the name of
This we will copy the code and put it there only. This this is called Marvin dependency. You need to add the Marvin nature to that. You have to do right click and then configure and then convert to Marvin project is there, right? If you convert it to Marvin project, currently I'll not do this, I'll do it here. If you convert it to Marvin project, then this will get converted to Marvin. Okay, I just need to give group ID, please and give finish. So currently this project is a Marvin project, and if you can see, I have what is the difference between this project and this project? It has form.xml, right?
Okay.
That is the only difference. You open it, form.xml. Here you can add the dependency. Dependency hierarchy is there, right? You can add the dependency. So where we will get the dependency from? We will get the dependency from here. So group ID, group artifact ID version. If you mention it there, this jar, and you can download the jar also here. If you see, there are 12 MB jar is there. So this jar you can directly also download. Download and manually add. If you can see, the jar is getting downloaded. I'm manually downloading, but the same can be added through your program. Like here, if I mention here if you can see the XML file, it has everything. All I need to do is I need to add this. I need to copy this and then paste it here inside. Plugin. Dependency. So it will automatically download. If you can see, it's automatically starts downloading the dependency management, everything from the internet. Right?
So that automatically goes and fit into the Maven.
Yeah, it automatically goes there and downloads.
Instead of copying it, it does automatically goes to the POM and it adds to,
it will go there and it will download from the internet. This is called as dependency resolving tool. We will say for all the projects, because you may need to change the version in the future and all. If you just change the dependency, the artifact ID and the version here, it will download the respective jars, and then you can build the jar here. You can try the Marvin build; it will run. Got it, Ji? But for our example, we are just adding it. But for project and real-time project and all, we'll use this. And for Spark related project, once we started coding on the Spark Scala related, we will use 100% Marvin only. We will not use the manual jar. For this Hive purpose, we are using manual. That time we will see more into how to change it to POM, everything. So everybody is clear in this one?
Yeah.
Yeah. Yes.
Okay. So this is fine. So for this, currently for Hive, I just added the jars from the class. Sorry. Right. So for this, I just added from user lib Hive and then lib. I added those all the jars so that the dependency is solved. After this, what I'm going to do is I'll create a jar out of this export and it's jar file. I'll just give a name strip.jar, finish. Okay. it created a jar in my desktop. So once I create a jar, all I need to do is I need to go to the I need to add the jar into my Hive runtime environment and then create one temporary function. That's all I need to do. So I am going into Hive. So I went to Hive and let me use September, our database. I just showing the tables, whatever the tables available, and after this, I have to give the jar. If in order to add the jar, all we need to do is we need to Hive steps. Go to Hive, type add jar and jar name. Full path we have to give. Here jar name is we need to give the full path /user /cloudera /desktop /jar name. Okay. So here add jar /user, not user home. Like Linux is always home, Hadoop is always user. So currently we have the job in Linux only. So I'm adding it in here. /home /cloudera desktop jar name /home cloudera desktop strip.jar semicolon. Does not exist. Jar, some issue with the jar. It is small s. Okay, spelling mistake. So it is added this jar, added resources. Okay, this is added. Now what we need to do is we need to create one temporary function for that. Okay, so let's create one temporary function. The function I'm naming it as strip, create temporary function, strip and then strip. This is the class name which we have created. So if you see this, here we have the class name as strip. That's what we are giving here. That's what we are giving here. And this name we can change. Create temporary function, anything we can give. Instead of strip, let's remove like that I can give. But this one as strip, it will take from the class name. Okay. So I'm just create temporary function strip by strip. So now the function is available in our Hive environment. So I can start using the function. Select test. So I can directly run against any columns, but currently I don't have a data to run the example. So for that, what I'm doing is I'm just using some table for the temporary purpose. User info ext. So that is a normally I did not ran the use the function. Now let me use the function. Strip. If I did not use the characters did not trim, and if I use the function, then the whatever the extra space is there that get trimmed. So that's how we can create a user defined function here. There can be n number of functions we can create. Whatever the function is required by the project, that we can create. This is just example one. Got it, Ji? Anandji, Anbuji, and Ganeshji, Shalabji.
Ariji, the strip is used as a class, right?
It is a class. We added it there.
No. On the Hive. When you try to remove the empty space. So select the class, right? That's a class, right?
Correct.
Then you use the same syntax which you use for SQL.
Can you mention a strip of any column name or something?
You can mention, but if it has data, then it will come. If it does not have any data, it will display the same result only. So ID, there is no idea. Okay.
Can you go and check any of the table and then.
So user ID. Oh, it works the same way. And if you want to see the second example, we can see user ID comma 1. It will remove the 1. If you see the last one, it removed. Correct? A11 it removed. A21 it is removed. That is the function overloading with the second method. User, if we give just user ID, it removes the empty spaces. If you give user ID and comma one more argument, whatever the argument you have given, that specific letter it will strip off. So currently we just gave 1, so that is been stripped off.
So what happened to A12?
Huh? Nothing happened.
A12?
Only the trial character will get removed. It did not happen A12. Only the last and first from the trial prefix and suffix.
Okay.
This is last 2. This is the last one. So like that. If I give 2, then 2 will get affected. So if you see 2 A12, now A12 is affected and A22 is affected.
Okay.
It is just an example function. We can write any function. That's how we wrote inside the Java. Like it is just a strip function. This function is already available in Java. So we just used the strip function. This is what it does. Okay.
In real time, you will be doing this kind of operations. I mean, this kind of.
We never used UDF function in our projects, but if we want to use, we will. It depends on the requirement only. For example, same way only we need to go for that. But only thing is you will not be able to create function each time. So for that, what we do is we will add it into the Hive starting script. There will be one script where Hive will start. So we'll give the script to admin and then he will add it to that itself. So that whenever the Hive starts, this function will always available for us. That's the one thing we will do. Other than that, the procedure is same. We create a jar and then we will give it to them. Then they will add it. The use cases may vary. Sometimes you want to add like 5 columns. You may want to like take it and do some kind of join or do operations inside. That depends on the business use case. But this is the way we should write the programs. Okay. Vignesh ji, Shivaram ji, Ganesh ji, Selvam ji, and Anbu ji, Anand ji, and Basil. So everybody is clear with the procedure?
Yeah, procedure is fine, but again, the writing and
writing and all, yes, that will quite sure it will take time. If you try, you will be able to do that for sure.
Okay.
Okay. So these are some examples. Like we created a lot of files. How to create some different files and all that we are just using. Anyway, the file part we will do the separate video for that. Currently, we'll move into yarn. This is about Hive. So we just required to check about the file formats which we will cover it. There are some more case studies required for the file format. So I'm just preparing on those things. That is why we are not able to take it today. But yeah, we will make it. So yarn. So yarn is nothing but it is yet another resource manager. That's what we saw yesterday also. So what is yarn? Yarn is it came with the Hadoop 2.0. So if we wanted to come to 2.0, what is the issues which were addressed in 2.0? So there are few issues with MapReduce 1.0. So there is something is job tracker is a single point of failure. So if you look at the MapReduce function, we have job tracker for the entire cluster. For the entire cluster, right? For the entire cluster, we have only one job tracker. If the job tracker is failed, then the entire cluster will fail. Correct? And if let's say you are running 5,000 jobs in your cluster, 5,000 jobs in your cluster, entire 5,000 jobs life cycle is maintained by job tracker, and it is a master node, right? So if we take MapReduce logic, this is job tracker, and everything is will be task tracker. There are multiple n number of task trackers can be running. Correct? So this is a job tracker with task tracker. Job tracker, these are task trackers. Correct? So if job tracker fails, then the entire cluster fails. Have the availability over there. Yeah, any doubts, Saloni?
No.
Okay, I'm speaking. Okay, so if the job tracker is failed, then the entire system is failure. Then it's a single point of failure. Then the entire cluster will not be able to submit any jobs or will not be able to retrieve anything. And when I say job tracker and task tracker, it is related to processing. It is not related to story. Like it is not related to how the data is stored, how it is retrieved. No, it is related to processing. Job tracker and task tracker is related to how the data is processed and how the job is run. That's what we use MapReduce 1.0. And then job tracker is doing a lot of works because it has to schedule. Let's say we have 5,000 jobs, entire 5,000 jobs life cycle, like where it is started, it is end, everything. Only job tracker has to manage. If any one job fails, job tracker has to look at the job and it has to reschedule the same job, and then it has to finish. If any one job fails or any one task fails, it has to take care of everything. So there are overhead in the job tracker itself. So that is also one more reason. And then maximum capacity of 4,000 node in a cluster. So when we are having a thing like this, job tracker is running in a master node, a special node, you will have obviously the limitation to run the maximum number of jobs, maximum number of nodes. If it crosses, you may not have to provide ability for all the nodes. So that is also one more issue. And now no support for non-MapReduce application. So non-MapReduce application will not get any support due to its nature. Like MapReduce has to run job tracker, task tracker, everything has to go only that way. So due to that, it does not have any other non-MapReduce application we are not able to support. And wastage of resources. So this is one of the very important point. So what is wastage of resources? When we submit a MapReduce job, it takes default number of reducers and maps and reducers. Let's say map is running for 2 minutes, and while starting itself, the reducers and maps will be taken into control for the specific job. So till the map is completed, all the reducers were kept idle for that maps to complete. Even though if job 2, let's say job 1 is running map and it is running for 2 minutes, and by the time there is one reducer which is being blocked for the job, and one more job 2 is running on the same time. It has completed map. It has completed the map phase. It is waiting for reducer. In that case, this reducer will not get allocated to this job 2 in map reduce 1.0. Due to this nature, there are a lot of resource issues were happening because some resources were idle, but still some jobs were not able to run on the cluster. So these things are happening in Hadoop 1.0, which is map reduce 1.0. These things were removed in Yarn, which is 2.0. So one major thing what happened is, and also if you see one more thing which we need to note here is, in job tracker uses all the RAMs to manage only the, like job tracker uses the RAM, memory and the CPU capacity of the master node, which is only one single node. Correct? Job tracker uses the RAM, like memory and the CPU power of the only one master node. That node has to be special node and powerful node. Correct? At the same time, even this data nodes, this also has the CPU, memory and CPU cycles. So we can use this also. We can use this also to run a job. So that is what happened in 2.0. This is Yarn. So Yarn, what is Yarn? Yarn is nothing but there are two components which has happened in the processing. One is we have to run cluster management. We have to manage the cluster. Okay. So what is the cluster management? Which how many nodes were there and which nodes are free? Those things we need to manage. That is the one thing. Another one is running a job and running a MapReduce program or running whatever the things. Okay. So that is the main difference. Yarn, after introducing of Yarn, what it does is it just takes care of the cluster resource management. It just take care of the resource management, and MapReduce will just do the data processing. That's what happened in Hadoop 2.0. Okay, what do I mean by cluster resource management in this scenario? Let's go there. So let's say, so till now everybody is clear with the concepts, whatever we are seeing till now. Anbuji and Anandji and Ganeshji, Selvamanji.
Yeah. Yeah.
Okay.
So it's a backup of job controller.
It's a back. What's a backup? You said backup.
Yeah, it's backup for the.
Correct. It is kind of. It is a version 2 handling the way of job cluster
schedule.
management. You would say not job controller, job scheduler.
Job scheduler. Yeah.
Scheduler and management. It does the management also. Okay. So what it does is cluster management. That's what we were seeing. So idea of Yarn is to split the functionalities of resource management and job scheduling and monitoring. So there are two resources. Let's say, let's think this way. There will be two services. One, what it does is first service, which will does is, okay, first service will request, okay, I want to run a job number 1 I want to run, and I need one CPU, one core CPU cycle, and then I need 200 GB of memory to run it. Give me. That's what this request will go. And what Yarn will does is, Yarn will check, okay, Yarn will know, what all the things, what is the cluster current availability, how much load is happening, everything Yarn will know. So this will allocate this as a container. This will allocate, okay, you asked for 1 core and 200 GB. Okay, take this. Let's for our use case we'll take 2 core and 200 GB, and Yarn will result, okay, you will have two containers you have at this same thing. You have each container 2 into one container will have 1 core and then 200 GB. You can have it. Sorry, 100 GB is a single one container. So it will allocate, and then after that Yarn will not do anything. Okay, the whatever the job requested, like whomever requested the job, that itself will take care of the entire job. So that is the overall idea here. We will see the technical aspects, like we named it everything. So that technical names you will see, but overall this is what happens. Like job 1 will request and Yarn will provide the resources. Once the resources are provided to the job itself will take care. That will be taken care in the data node itself. It will not, there is no global monitoring for this jobs. So that's what happening. So those things are called global resource manager and per application master. Here in 2.0 Yarn, each application is treated, each application's life cycle is handled by application master. So application master is a program which it's a service which controls each job. Let's say you are submitting one job, that will be entered, that single jobs life cycle is managed by application master. So application master will get created in data node. Okay, so we'll just see it like this. This is our cluster. The cluster will not change because name node is there, those things are there. Everything will be there. Let's say client is, we are applying one job 1 we are applying. Once we apply the job, for the single job, one application master will get created. We'll create one application master. This is called AM or application master. Application master will get created in data nodes. If you can see, it is created in data nodes. Okay, and then what it will does is, okay, it will it will check, okay, I need this much containers, I need this much memory and all. So application master will request the global resource manager. Global resource manager for the containers. Okay, all I need is, I need 2 containers to run all these things. Please provide me the containers. Then global resource manager, what it will does is, it will allocate the container in here. It will allocate 1 container. It may allocate here 1 container, because global resource manager knows the cluster status at any point of time. Okay, so global resource manager will allocate 2 containers here and here, and it will send back the details to application master. Now the application master will execute the jobs here and then here. It will get executed in these 2 containers, and then if the job fails, if this fails or something happened, then it's application master's responsibility to retry the job. The entire life cycle is managed in application master only. It's application master's responsibility to handle the single job. Okay, so once that is completed, application master will release the container, and then it will tell the global resource manager that it is released, and then application master also will get killed. This is the life cycle of the one job submission. I'll just tell it once again. Okay, first the client will submit a job. Any client will submit the job. once a client submit a job, application master will get created. It will get created at any data node wherever we are running. It might get created over there also based on the availability. Okay, so application master will get created. The application master will request the container. The container, it will request for, okay, I need let's say I need 100 GB of memory, and then I need five containers. I need 5 containers, CPU cycles, etc. etc. I need 4 cores. This is what request will send from here to there. And then global resource manager will allocate the resource, and then it will send, okay, these are all the places allocated resources. There, application master will run the job, and then it will complete the job. This is the life cycle. This is what the life cycle will happen. Okay, this is the one part. Everybody understand this part?
Aruchi, why do we need an yarn? I mean, we can directly, the job scheduler can do that, right? Which scenario we use the yarn then?
Okay, so what is yarn?
It's a resource manager.
Yeah,
I mean,
here we have the different components performing different things, right? Which job job scheduler we can replace this with?
Okay.
So there are we have some other job scheduler we may have, but for the specific of Hadoop nature, we might not use other scheduler. Correct. And this is not external scheduling. This is the internal job scheduling. We don't know any of what's happening, but yeah, we have a lot of control over these things. How, like, all the memory given, everything we have a control, but it is an internal job scheduling, right? So that's why we need yarn. And also it's the nature of running in a cluster way. That is why we need it.
Okay.
If you can tell me any other job scheduler, I would understand it and I'll tell you what is the difference between that and this. But as this job scheduling is happening internally.
No. What I was asking, before without yarn, using the job scheduler, the existing job scheduler.
Job tracker. You mean job tracker, right?
Yeah, job tracker. Yeah, job tracker and the task tracker.
Okay. Yeah, that's, I understood this. So what is the thing is, here each job will get its own application master, and if you can see, the application master is created in data nodes. So that is giving us huge difference. Previously, what happens is the control of the each job was happening in job tracker, right? So that was a headache. Job tracker was handling. Correct? If we have 5,000 or 6,000 jobs, every control, all the control has to be, all the entire jobs life cycle has to be handled by job tracker. That is the overhead for job tracker, right? Yeah. Currently, that is being lifted off from job tracker and it is given to application master. And application master is a master for only single job, single application. So that is a huge difference. We took the burden of job tracker, and then we are creating 5,000. Now what will happen if the 5,000 jobs are running in a yarn cluster 2.0? 5,000 application master will get created, and each will handle its own program, own life cycle. Correct? And also that is those memory is utilized in data nodes. So if your cluster is less, you can easily add data nodes and the parallelism will increase. Correct? Do you understand me?
Yeah.
So that is a huge difference and that's the benefit. While going to 2.0, that's why this architecture came.
Okay. So even this application master also again execute the tasks in a task tracker.
Job tracker, task tracker is same. But how it executes is this way.
Okay. So it has an intermediate functionality called application master who talks to the global resource manager.
Yeah.
It allocates the resources and it goes idle.
So yeah, correct. Global resource manager is nothing. It just knows how many cluster, what is the status of the current cluster. That's what global resource manager knows. And how does it know? Each node will have one node manager. Node manager, each node, it is a per node. It will send the status to the global resource manager about the status. So based on that only, global resource manager will know the cluster status at any given point of time. And node manager is installed per every machine. It's each data node will have node manager, so it will be used. And this is called containers. Container is a place where actual program is getting executed. For a single program, for a single application to run, there can be n number of containers. And number of containers can be requested by client through the program. So we will define this in yarn program and all. We will define this. Like we will ask, okay, this much memory I need, this much memory I need. We will define everything, each and everything we can define. We'll ask. So one more thing what we are benefiting is we can control the memory. Like one application 1 might have 100 GB of memory. Application 2 might have 200 GB of memory. So that is possible. So there are only 4 components. One is application master, another one is global resource application master, and application master runs the executes the job in containers, and containers will be created across all the nodes based on the availability. And this is the MapReduce part. Processing will happen here and here, and the controlling, the management part of the cluster is here. Global resource manager and node manager. Global resource manager is nothing but it knows the entire clusters where free resources are there, where it is being more utilized, everything that knows, and it will know by the from the node manager. Node manager will send details to the global resource manager so that it knows, and then it will allocate the containers to the application master for each application. And once application master started, it will directly communicate to clients. It will not interrupt with these things. It will directly communicate to client only. And once it is completed, the containers are released. So here, I'll just show you one more picture. So this is what happening in MR 1.0, right? Client, job tracker, that is a master, and task tracker are there, tasks are running. In 2.0, if you see, it is changed. We have a resource manager, this is global resource manager, and we have node manager per node. And each application, we have application master per each job. So application master, what it does is, if you see the color of the colors, this application master is controlling this container. And this application master is containing 3 containers. Here one container is running, here one, here one. Correct? So that's it. Application master is connected to resource manager. It gets the container from there. Same thing. You can go here. Here also you can see. Once you go into the Cloudera, you can go to Hadoop, resource manager, node manager. We never go to node manager. That is not, but if you want to go, you can go, but it's not necessary. But if you are running any job in Yarn, this is a place you will debug, you will see the errors, you will check the logs, everything. This is called as, we call it as Spark UI because we see all the Spark jobs here. Okay. So this is a node manager. This is a global resource manager. How many applications are running, and tracking UI is there. Here you will see the logs also. How many CPU V cores are there? How many allocated memory, reserve memory, what is the allocated CVV cores, running containers, final status, state, everything you will see in this place. And what is the application type? And we have different kinds of running states. Once you submit a job, it will go into the submitted phase, and then it will get accepted by the resource manager. And then what happens is once while the resource is being allocated. Till that time, it will be there in an accepted state. So this is a running cycle of the program. The program will be in accepted state if you don't have enough resources in your cluster. Let's say you are requesting for 500 GB. Let's say we are requesting for 500 GB of memory. 500 GB of memory and 4 containers. Our cluster does not have that much memory currently, but our minimum requirement itself this. In that case, what happened is our program, our job will not go into running mode. It will be there in accepted mode only. It will waiting for resources. The status will be waiting for resources. Right? So that's what will happen. After that, it will go into the running mode. After that, it can be finished, killed or killed. Finished, failed or killed. Anything might happen. So there are schedulers, which it's a kind of advanced thing. There are steady fare scheduler, instantaneous fare scheduler. Those things we can. It's kind of advanced. We will see it later. Okay. So till now, everybody are able to understand what's happening.
So this status will go automatically, right? From new to saving.
Yeah, status will go automatically.
So wherever if
for you to check.
Yeah. Okay.
This is for us to check and find out. It's like a monitoring tool for us. Like what is the status, whether any job failed or not, that we can see here. Status will automatically.
This one is.
Yeah, Ji.
Aruj, actually, this one is available only from Hadoop 2.0, right?
Yeah, it's available from 2.0 only. Correct.
Because the reason, because the 1.0, there is a name node, they won't have any standby and all, right?
Name node standby. Yeah, standby will not be there. No, but this is not a reason for standby. Is not a reason for this. This is for processing, right?
No, I'm okay. So I'm asking because of that, because there the Hadoop 1.0 they don't have, because here from Hadoop 2.0 onwards only the name node standby and all came in the
correct.
The concept,
standby also
right?
came from 2.0 only.
Okay. So in that to especially to monitor all the jobs and everything, the yarn has been introduced, the scheduler.
Yes.
Okay.
It is not exactly scheduler. It is a resource manager. It manages.
Resource manager. Okay.
So what was there in the 1.1 then? 1.0?
Nothing. It was just job tracker, task tracker.
Okay, so there was no resource manager. Okay.
There is no resource manager, nothing.
And also I have one more question. Because in the 1.0, if it is an because in 1.0 we don't have that that one cluster cannot able to talk to the other one, right?
One cluster cannot talk to the other one. 2.0 where we are talking, Ji?
No, in 2.0 sometimes the for the high availability, the files are copied on the other node, on the other cluster of the node. It used to have the one copy of the files, right? HDFS file.
That is, you are talking about the replication factor, right?
Okay.
You are talking about the replication factor. If you mention 6 replication factor and then that can be copied into the other cluster.
Yes.
That facility is there in 1.0 also. It is not.
Okay.
You could have had it in 1.0 also. That is a different case.
Okay.
And if you want to bring the data from one cluster to another cluster, in what we use in Prodes, this CP, there is a command called discp. This CP is nothing but it's a parallel way of bringing the data from one cluster to another cluster, talking two clusters. So that is a command we use. One cluster to another cluster. Data will be green.
Okay, I got it.
Aruji, have they released 3.0 version too?
Recently, yes, there is a 3.0 version, but it is not yet used in any projects till now. But yes, the 3.0 is released. SGFS 3.0 is released.
Okay.
And there are some changes in the 3.0. We have one video for that. I'll just send you it over. 3.0, but it's in Tamil. I'm not sure everybody knows. Just watch this video.
Yeah.
That's the changes, whatever we have in 3.0. It's not yet implemented. That's why we did not use it.
Okay.
Sorry, I said it only one. Okay, just watch the video. You will get to know what's available in 3.0. Okay, so any other questions in Yarn? Everybody able to understand? Ganesh is LMG and
Yeah, I am fine with that.
Yeah, okay.
Yeah, I am fine with that because I had only little confusion. Yeah, I got clear. Yeah.
Okay.
Ji, this is Selvam.
Yeah.
No. How we implement this yarn in our project, in the sense while installing the 2.0 we do this, or how do we handle it in a practical way or from the project perspective?
If like while running a program, nothing. If you need to submit a job, then it will take in Yarn itself. That is the one case.
Okay.
If your cluster is Yarn enabled, then it will automatically take care. And if you want to specify there, if you are running Spark jobs, then you have couple of things, because Spark you have to specifically explicitly mention how it should run. So those things we need to take care, and you have to mention Yarn in submit it in while submitting the job. You have to mention how it be run, master Yarn client mode, cluster mode, that you have to specify. Here it will automatically run. So if MapReduce, it automatically takes. If it's Yarn enable, it will take care.
And we don't do any kind of program or any kind of management on Yarn, correct? Apart from submitting and monitoring.
Yeah. Apart from that, what we will do is we will not do any programmatically, nothing. One thing we need to do is we will specify the resources required for us. We'll specify number of executors we need. We'll specify the RAM we need. We'll specify those things we need to specify in the configuration. While running for each job we need to give. That is the one thing about this. If you don't give, it will take automatic.
So in that scenario, okay, in that scenario, Aruji, because as a developer, suppose I'm working on a. So in that scenario, I don't know about all the production configuration and other thing, right? So in that scenario, how can I able to say that this job is need this much, this job is need this much resource we need, because we cannot able to say anything about in the production environment, right?
Yeah, no, it's not true actually. One thing is you will develop these things from dev and SIT and those layers it will go, and you know about your application and how much data load you need. That we will know it. So based on that, we will tell us, okay, we need this much for our job to run on this time. If you reduce it, it will increase the time. So for our data, let's say you have 100 GB of data coming, and if the clients gave us a ETA, let's say it's a ETA is 10 minutes or something, then even though you wrote very best optimized program, you might sometimes you end up requiring minimum level of resources. You need, okay, I need at least 10 cores and I need GB of RAM for my job, and I need 2 executors or whatever it is. This we need to give. That's what we need to communicate with the admin team to get it done. If then obviously if we didn't get this, what will happen? Sometimes the program might crash due to memory exception or something, or we will exceed. So in this project, if we need to closely work with the teams only. We will know the configuration of every cluster. Like in our project, in my project, I know what is my prod cluster, what is everything, because then only we will be able to run the program.
Because the something is because in our company and all the Teradata and all, our QA environment is half of the amp and half of the node capacity compared to production and QA. So data volume, yeah, we are managing with similar, but this kind of hardware structures or QA is half of that. So that's the reason I asked. Okay.
Yeah, same here also. Like even Hadoop also you will have the same only. Production is always high. Like our dev UAT will be less than that. That is for sure. But we will test the less data in this environment. That's what we'll do.
Okay.
And we have one pre-prod is there. In pre-prod we'll test the load testing. So there it will have high configuration. So the environment will go like this: SIT and then UAT, and then we have one more the pre-prod, and then prod. So all this environment, it will go through all the environment.
Almost. Okay, I got it.
And RJ, on that line, I wanted to ask one more thing.
Yes, Ji.
When you mentioned that for this example, you mentioned 5 executors, correct?
Yeah.
Okay. Suppose for example, for the 100 GB data with all this RAM, even though I given 5 executors, it will get it done by 3 executors. So other 2, will it get released, or will that be also be there till the job completes?
It is based on a configuration. We have something called dynamic allocation. So in dynamic allocation, if you make it as true, and then we have to give minimum executor, maximum executor. So you have to give minimum executors 3, maximum executors 5. So in that case, what happens is, once your job is started, till the end, it will always have 3 executors, no matter what happens.
No matter what, okay.
But if the data increase, it will go up to 5 executors.
Okay.
It will stay there in 5 executors, and if the data is reduced, then again it will come back to 3.
Okay.
So that is if you enable dynamic allocation true. If you make it as false, then yes. If you give 3 executors, then 5 executors, and till the end 5 executors will be allocated to that. Whether or not the job is running or not, it doesn't matter because it is allocated.
Okay. And I believe all these external this yarn and all is pay and use, correct? It means like in cloud terminology, how much we used, for that we need to pay, things like that.
If you go for a cloud, yes, it's kind of pay and use. You can run how much you run, that much only you would pay. In cloud and all, yes.
And do we have any kind of running that during the transient phase? Means that whenever I want to use, I can invoke the yarn function, and then once I'm done, I can complete that model.
Yeah, you should be having it in cloud related things. I am not aware of that, how it's been done in cloud, but yes, certainly there should be something available for that front, because that is I've seen a lot of things where you're going like that only. Whenever you want, you can switch on it, you can switch off. That's possible. In AWS itself, it's possible.
Okay. Because it is installed on top of the HDFS, right? So once HDFS is installed, then you install this yarn, or it does by default it will be installed.
Yeah, once if you are manually installing, yes, you have to install HDFS and then you have to install yarn. Or else it is already available. If you use 2.0, it's already comes with the package. In Cloudera, it's already there in our systems.
Yeah. But in real time, in production or in companies?
In production also, nobody is. As far I know, everybody uses some kind of distribution only. So we are using Cloudera 5.9. So the same goes here. Some would use hot or not. And if some admin wants to install it from scratch, yes, then they have to install it separately using the jar. They have to install HDFS and Hadoop. If they install Hadoop, it comes with the package. Hadoop means what? HDFS and then MapReduce, right? So it comes in the package itself. Okay.
Samuji, today's class, I feel that the yarn is little dry subject area. I'm not sure why, because of the, I don't know.
Yeah, yarn, if you see the first time, yes, it will be like this only. Just go through the video once again and just watch the PPT. It's a very
Sorry,
simple in nature.
I might be little wrong in that, but that's what I feel. So far,
No.
the classes were little informative, and SQL, when we talked about that, we were able to relate with you. But today class, some of the topics, just assuming that okay. But as a nutshell, I just want to make sure yarn is a resource management and a scheduling tool where we can just view the jobs, how it runs, and things like that. Correct?
Yeah, exactly. Yes, but why we added yarn? Previously, we don't have yarn in our syllabus. We don't have it. But without yarn, you will not be able to understand Spark, how Spark runs, how to optimize these things. That we will not be able to understand. So that is a reason. Even though it is a kind of complex, it's not complex. It's very simple, but it's kind of we need to understand this. That is
The dry subject. It's not a complex, but it looks like a dry subject. That's what,
yeah, maybe for you it's dry, I'm not sure. But still, it is,
I think
it's very interesting. But fine, it depends on each person's interest, right? Yeah.
sorry.
I think actually it's a whatever Ganesh is saying little bit, because it's a really something is little bit, because first time we are hearing all these things. Because so far
completely
all
understand.
these things, no. And other one more thing is, so far whatever we worked, everything it is related to already we worked. Suppose Hive, it's related to SQL, Scoop. Okay,
Yep.
we are extracting data and everything. This is the
Yep.
first time we are realizing the real Hadoop related concepts and especially the parallelism. That's the reason we are having little bit thing. I think maybe whatever you are saying is correct. If we will watch this video maybe some 3-4 times continuously, so we will get into that idea. Okay, this is the thing, how this way yarn is working. Yeah, definitely, it's really yes.
Correct. So if
But
you need,
Arjit,
I will add
thanks for
Tamil
bringing
video
the
also.
topic.
If you think
And
Tamil video will, we've taken the same
Yeah.
concept in Tamil. If you think somebody of
Okay.
use Tamil, then I'll upload a Tamil video in our folder. You can watch that. That you
Okay.
will understand much more clearly that.
yes, please, Arjit.
Yeah.
I think
Yeah.
I need to hear it from my own language to hear it
Okay,
out.
I'll add it.
Yeah,
I'll
yeah,
add
yeah.
it.
Yeah.
Yeah,
But,
I'm also. Yeah, you will add it.
yeah. So,
But actually, one thing is, at least thanks Aruji, because you bringing into the concepts, because
Concept.
we
Yeah.
came to know. Okay.
yeah. So I'll just repeat only base things which is very important in a project or everywhere. It job tracker was just replaced. That's it. Job tracker it is taking huge load in 1.0. Currently,
Okay.
it was handling everything. Currently, that is being like it's just distributed to application master. That's all it is.
Okay.
Other than that, yeah, if we go into details, yeah, we need to go details and how it's done. Yeah, but anyway, I hope
Okay.
with the idea, overall idea, that's what I expect from this session at least, because
Yeah.
I will not be able to understand everything, because I was working in this for 2 years, so it's not expected to. I may get interested in that maybe, but same
Okay.
thing we will not be able to like understand in 1 hour. But I hope it gives some
Yeah.
idea. We'll see it more, because after once Spark starts, we'll always use Yarn only. We'll submit jobs in Yarn. We'll go
Okay.
and see this. You will unable to understand. Yeah, but fine. It's good. I'll add the Tamil video also in our folder.
Thanks, Arjit.
Okay. Thank you.
Okay.
Thanks,
Then tomorrow also I'll see. We'll try to demonstrate some more Yarn and concepts, and we'll start seeing the things. Okay. Any
Okay.
other doubts or anything else? Any others?
RJ, if you are doing some demonstration, can you just have at least a real time some samples or pictures, if that help us to understand?
Yeah, sure. The real time, it is whatever we were seeing still now, even in Hive, everything. It's kind of the same operation only we'll do. Only the use case differs. Okay. Only the
Okay.
use cases, the concepts, that's what it will be differ, but the same thing only we will do. Yeah, but here also
Okay.
we will do it. No issues.
Okay, Ji. Thanks.
Yeah, thank you.
Thank you.
Yeah, so any
Thank you.
others?
Thanks for
Yeah, Shivaramanji, Vigneshji, and did I miss anything? Anbuji or Anandji, everybody got it, or everybody's?
Yeah. Yes. Actually, the only thing is, I need to see the video at least another 1 or 2 times.
Yeah,
Then only I can able.
Yes.
I can come up.
Sorry.
Yeah.
Sure, guys. I hope today class is useful and interesting. Yeah, we'll see in tomorrow class, and
Yeah.
I'll add the Tamil
Yeah.
also. Thank you. Thanks, everyone.
Yeah. Sure. Thank you.
Yeah.
Thanks.